today's session, just I will start with the submission of the job related to Java. In the earlier session, we have seen some of the aspects related to MapReduce one, and of course, the other kind of the considerations like job tracker, task tracker functionality, and how we are making use of those particular functionality to the job submission, all those kind of the things we have seen. In the today's session, of course, as we are all aware that entire Hadoop environment is running on top of Java, no matter whether you are using Spark or whether you are using PySpark or any other Python kind of the code in the context of the Hadoop. So definitely, these are all the things running on top of JVM. Okay, so it is always preferable so as to um, know how to submit the jobs related to Java code also. So for that, let me give you the objectives of the session. So the very first thing is just let me show you the configuration of jar file because in the earlier session we have seen how we are making use of the streaming file, Hadoop streaming for the submission of the Python file. Today we'll see the jar file orientation and then how we are going to submit the jobs to Hadoop cluster. So this thing we'll see Hadoop cluster. And next thing is sometimes there is a possibility of maybe you are getting some jar file and even you are not aware of what is the code inside that. Okay, in that case, how to get the class name and how we are going to how we are submitting. Okay, the appropriate um, only the .jar file info to the cluster. Okay, this thing will see to the Hadoop cluster. So this is another aspect. Next thing is just we are our most considerable part is MR1 limitations because before launching the MapReduce II or add kind of aspects, first we'll try to understand what is the suitability of this MapReduce one, and thereafter we'll be talking about MapReduce two and at another resource negotiation. Okay, these kind of the things. Okay, so definitely compared with the earlier MR1 understanding, these two are quite simple, guys, because that is the most intricate architecture. So, but whereas in case of MapReduce 2 and ARN, the developers of Hadoop and the designers, okay, given some simplifications and they came up with some analogy without having any uh, problems to understand the architecture and they have a lot of simplification they have done. So with this, just I will the context is here. So far, we are using some predefined cluster points. Actually, that is a Cloudera cluster I am using. Okay. So today, I thought of showing you the usage of virtual machine. Okay. So the usage of virtual machine. And on top of this virtual machine, we are having all the tools actually. Hadoop ecosystem tools, and as well as we are having Spark, all the configurations we're having, right? Okay. So now let me introduce the aspects of that virtual machine. Just let me see the entire screen I'll be sharing. Yes. Okay. So now this is the virtual machine I'm using. Of course, I already configured this. So this particular virtual machine, after installation of the virtual machine, I have taken the CentOS installation, and from that you can make use of the other installations. Okay, so once that is done, then I can configure the installation of the Java and all those kind of things. And some other points there is actually such as Cloudera and Hortonworks, they provide us some predefined images also. Okay, they are available, and we can venture those things also. Suppose, as definitely we are not the Hadoop admins, no? We need not know the initialization process and all these things, and pre-configured. Okay, virtual box would be available so that you can directly make use of those particular virtual machines, and directly you can start using all your functionalities. Okay, so that is how you can perform the or make use of the conventions. Now, here also the same convention forms, nothing changed, just you can refer ls and Hadoop fs hyphen ls, like that, the same way without any change. But only the thing is, as we are using the live cluster, that is bit faster, friends, if you see. But whereas if I configure my virtual machine, then obviously it is taking some time. Whereas in our all the earlier examples or demonstrations we have seen, those particular things are directly. If I am submitting immediately, I am getting the response without any waiting. But here it will take some time. Definitely, you are going to realize that what is the difference between the live cluster and as well as the cluster which we are managing basically, right? So this is how we need to see the options. But the fundamental thing is, of course, we have seen the local file system understanding and Hadoop distributed file system and all those commands and all those orientations we observed. Now the idea is, of course, Python job submission and all those are okay. But as we are in the process of big data and Hadoop development, at times we may be getting some reference of the Java also. Because still, though Python is heavily used in data engineering and data science, but still in the big data scenarios, there are plenty of use cases and plenty of projects running on top of Java. So I thought of why can't I scope that particular point also? Because later, after completion of this particular thing, you should not go back and verify. So we missed out this kind of thing. Okay, that's what the mandatory aspects, maximum I am covering, so that you can be get benefited once you enter into the projects of this big data kind of the scenario. So in that particular case, guys, in case of Python, maybe directly I can use .py kind of things, where there are editors, Jupyter Notebook or PyCharm or even Idle, like that we're having different editors. And of course, the Java, the best editor I feel is Eclipse, and of course, NetBeans also. Okay, that all these kind of editors are available. And for the time being, just I am taking the Eclipse editor here, guys. So if you observe this kind of editor, so I'm having the Eclipse editor here. Now the aim is, guys, just how we are going to submit the job with the notion of the Java orientation. So for that, let me give you the command first. So this particular command, what it says is, just we have seen some of the job submissions related to Python. Now in case of the Python context, let me give the command first. Python context of MapReduce job submission. Okay, here you remember. Okay, so just we are submitting like this. Hadoop jar, and this particular jar is streaming jar, friend, actually. Now the predefined one, Hadoop streaming 3.2.2. Okay, that is the predefined jar. And in the continuation, just we need to specify the files information. This is the these are all the job files. Just we have seen mapper2.py, um, whichever the files I'm having, reducer2.py. Here it is not required. So just hyphen in front of this files only. Mapper2.py, reducer2.py. And once this is over, again I need to explicitly mention what is the mapper2.py, what is the reducer2.py. Okay. And thereafter, input as usual. Input, we have taken that purchases dot txt and mentioning the output as mr1 underscore job, some output we are giving. So this is the way how we need to submit the Python based job submission to the Hadoop cluster. But now we are talking about the Java context of MapReduce job submission. Now we need to understand a few points, friends, here. If you remember, we have taken some four MR steps actually. If you see the MR steps, the first one is the split phase. The second one is the map phase. The third one is the shuffle phase. And the fourth one is the reduce phase. Out of these things, this thing is a framework activity. This has to be the developer activity. This is again framework activity. Reducer also developer activity. That means you need to design some mapper class and reducer class. Okay. So no matter whether you are working with the Python or Java, these two classes are mandatory. These two programs are mandatory. In case of the Python, we have seen mapper2.py, reducer2.py, and we are submitting the job to the Hadoop cluster. In case of the Java, how we are doing. So just observe here. In case of the Java, actually there are certain aspects, especially if I'm talking about the Eclipse orientation. First, we need to give the project. So within that project, I can go with the package. And within the package, again, I can specify the class info. Okay, class info. Now, after giving the class info, just observe here, friends, we are having the public class actually. Okay. This public class is nothing but the driver class. Sometimes we can name as the driver name or driver class. Generally, what happens is within the driver class only, we are going to specify the mapper class and as well as the reducer class. Okay, that means if I am referencing the driver class, then obviously my mapper and reducer, as I already mentioned in the driver class, I need not explicitly mention the mapper class and as well as the reducer class. So in that context, what we'll do is just the job submission, how I'm going to submit the job. Okay, let us see here. So accordingly, we'll understand the process. So here the Java job submission involves like this things. The very first thing is like Hadoop, jar. This jar is nothing but, this is not the predefined jar. Let me give the syntax first. User defined jar. After giving this, we need to specify package name dot driver class name. Package name dot driver class name. Hadoop jar user defined jar package name dot driver name. Input file output director. So this is, for example, okay, how I can do this is example. So Hadoop jar, what is your jar file? Maybe I am creating mr1.jar. I'll show you how to create the jar and all. Maybe I'm using the package name. Generally, guys, in case of the Java environment or Java development, we will use the reverse domain name system. Like, suppose com.sample dot www. So reverse naming on. Generally, what we say www.google.com, like that we say. But in the context of Java packages, reverse domain name system. It also will follow the same. Okay, some package name friends, whatever the package name we are having, dot driver class name as said earlier. So assume that here we are implementing the word count driver. The name given to this program, this class is main class is word count driver. So now you see Hadoop jar file we have created, and this is the package name and as well as the driver class name. And then we have to give the input file name. Assume that I am having my file name itself as the input, and my output directory is output underscore MapReduce. See, because Hadoop's native MapReduce code is Java only. So that's what obviously, if I am working with the native technology, I need not pull all the external entries. Okay, so directly you can make use of the Hadoop jar file name, whatever we are having. So just package name dot our driver class name, and then input and output. So just will see all these kind of things practically. Now, as said earlier, we can create. Okay, so just you can make use of this particular Eclipse. So here, file, new within this project, and after creation of the project, again package you can take and class. Okay, so now generally friends automatic obviously will be getting the jar files and we are going to submit those jar files to the Hadoop cluster. Okay, that's what just you don't worry about this coding and all. Just if you see these particular whatever the imports I am using, these are all the imports. Okay, these are all the imports which are related to your Hadoop environment. So path, interwritable, long writable, these are all the data types. How Java is having string and integer float. Okay, like that as a compensation to that particular Java code, we are having the text instead of the string, and long writable instead of long, interwritable instead of int. Like that, we are having all these kind of the configurations. Now you see, as I said, this is the public class word count. Here we are having the map and as well as the reduce class. So within this word count program, we are having the map and as well as the reduce class. So and main function, of course, again we are referencing the mapper class and as well as the reduce class and all these kind of the conventions, all the configurative settings and all. Okay. So now once this code is ready, maybe Java developers can give this particular code to you. And it is two types of friends. Actually, directly you can put the code, and from that point of code, you can lead the other aspects. In that particular case, just you open this particular code, and you can make use of this. Right click on this project, and obviously you will be getting some kind of sorry, not this. So just to right click on this, just to go to the export. Okay, export of this thing, and you need to select this Java kind of the consideration rather than all these other things. Jar file. Okay, next. Now here we need to explicitly mention the path friends actually home slash as we are using this Cloudera kind of the distribution, that is the default path actually, home slash Cloudera. Now what we are doing is just I am making use of mr jar file dot jar. Okay, so just you can use the next, and next it may ask you some kind of main class. So in that case, browse. Okay, your main class is word count. So just to select that. and give the finish. Okay, let it be. It will create some warnings, no problem. So this is the way how you can export the jar file. Okay, so just you see here, friends, one more time. Right click on the project, export. Just you can select the Java menu item. And from that, you just to observe the jar file. Next. And this path, path generally given by the corresponding admin within that particular home path only. Or else you can simply give the PWD, present working directory, where you will be getting the current working directory. So after getting this, just you can make use of the finish. That's it. Okay. Now, this up to this particular thing, just what we have done is we got some source code from the Java developers, and we have created some kind of bizarre files based on the given source code. Now let us go to the this thing, um, this terminal, and if you give the ls, see friends here, mr.jar. Okay, just now we have created. So we can see that particular mr.jar uh, as a kind of representation for our code. Now let us see what is the which are all the inputs available in the Hadoop distributed file system. Okay, remember friends, MapReduce is only knowing about the inputs of take the input from the HDFS and it is going to generate the output directly in HDFS. Okay, so for that purpose, what I'm doing here is just I'm making use of Hadoop FS-ls. It takes little time because as I already said, no? So this is not as much fast as live cluster. That particular cluster is having heavy machines. Okay, this again we are creating with 4 GB of the RAM and certain 20 GB of the memory. So within our system, it is a virtual machine actually. So that it obviously having that limitation. Now, if you observe the input, let me clear the screen. I want to display what exactly I'm having in the input. So Hadoop FS-cat, just you can make use of the input. Just I have created some technologies and repeatedly we are adding that. Assume that here we are going to find out the number of resources related to that technology. Friends, here only word count not only give the count of that repeated words, but many applications were there. Like in a team, if I want to get how many resources are there in big data, how many resources are there in Hive, how many resources are there in MapReduce context or Hadoop distributed file system context. So in all those cases, just we need to count those particular technology and we have to give the number. Okay, for Hadoop we are having 10 resources, for Hive we are having 15 resources. Like that, that is the scenario. Okay, so word count problem is helping you in sentiment analysis also. Like if you are talking about the Twitter analytics, or if you are making use of some Amazon um, buying habits of the customers, which product was sold more, or else how the products were rated by the customers. All these kind of the things, or having the direct connection with the word count. So that's what we feel always while learning these big data kind of the thing. And to understand the process, just will take that particular example. And of course, in the earlier example, we have taken some purchases data where different kinds of the products were there. And those kind of the products generally collect some kind of the price on a day or so. So just we have listed the product and as well as the cost information. And in the next example, if I want to submit all the sales data related to the product, so that those two scenarios we have seen. But in this example, just we were taking some kind of the input data, and that particular input data helps us to um, okay, so as to find out the number of capabilities, okay, available in the corresponding context or the corresponding technologies. So with this, just we can we'll be having all the things friends. So let us submit the job. So we are having this ls mr1 mr.jar. So what we'll do is Hadoop jar. Jar file name is mr jar. Now we need to take the package name dot class name as per the analogy. So just we'll go to the Eclipse. Here, there is no package name. Directly, what we are doing is within this SRC, directly within the default package only, we are adding the word count.java program. Okay, but of course, sometimes you can give that. You can give the package, and inside the package also you can give, or else directly within the default package also you can specify. That is all the wish of the program. Okay, there is no restriction or something. So especially in our case, we have not given any package name. So directly I can refer driver class name. So driver class name is nothing but the public class name. Whatever the public class we are having, just you can specify that particular class name as the driver class name. So here we have given word count, W and C as capital. And so the same thing can be used to specify the driver logic. Okay, now just you can mention word count and input file. So Hadoop distributed file system input file, whatever I'm having, just I'm giving this thing. And thereafter, I want to give you the outcome MR1 underscore output. Okay. So see such simple thing. Okay. In case of the Python, there is no jar created by the user, so that we have pulled that Hadoop streaming jar as a substitution. Okay. And thereafter, explicitly, I need to mention the files, mapper file, reducer file explicitly, and then mapper separately, reducer separately. Input output, of course, common in both Python and as well as the Java. And in case of the Java, you need not mention the reference of the input, hyphen input out, hyphen output. Even those things are also not required. Directly, this Hadoop command conveys the information about this is the user defined jar, which is the mr jar dot jar. And next, I'm projecting the package name dot driver class name. And then after the class name, whatever the input, whatever the name I'm giving, that is belongs to the input file. And after input, whatever the name I'm giving, that is the output. That is understand. So give this enter. So we have to be little patient. We should have little patience because in case of the cluster, if I am submitting, immediately we are getting the outcome like allocation of the ID and then launching of the job. And there immediately you can see uh, some problem. Let me see. Uh, Input already exists. Okay. So just to see here, no problem. So last time also the same. Hadoop jar. What is the jar file name? mr1 dot jar. And thereafter I'm taking the my class name as word count, and we are giving the input file, the output, just like that we give. Sometimes with the package orientation will be seeing that no problem. However, I'm having that jar in my cluster also. There we can clearly see. Mm, no problem. But I thought of giving you how we are going to export the appropriate file into the MapReduce orientation. Okay, that is the understanding. Yeah, no problem this time. I don't know why it stopped us earlier. Now you observe here, friends, submitting the tokens. So this is the job ID. Okay, initial job ID. So that particular job ID is preserving. Okay, it preserves up to the ending of this mapper and reducer code. And you can observe here, guys. Here also I am using Hadoop 3. That is the reason it is saying resource manager. Resource manager we have not yet discussed, but observe that while submitting your job to the Hadoop version 3, then obviously we are not having any job tracker or task tracker. Rather, we are having the resource manager, node manager, all those kind of the conventions. Okay, that is one thing. And just you can make use of the understanding. Like here, we are submitting the job to the ad. Okay, and there some input formats are there. I'll come to that, guys, because input format is related to the split function actually. So as said earlier, we are having the four phases of the functionality. The first phase, of course, the split phase. That is what we call the input split phase. So whatever the input I am taking, and Hadoop is providing some kind of the framework activity. That framework takes care about our input. So just it is making use of that particular input file, and it is trying to perform some kind of splitting process. Okay, it automatically does. We need not involve in that. And once that input is split into the records, again that input records will be given to the map phase. That's what here you observe. It is launching the map. And these map reduce kind of things is a parallel. It depends on the parallelism things actually. If you are referencing the Hadoop, which is a combination of Hadoop distributed file system and as well as the MapReduce. So if you are talking about the Hadoop distributed file system, it is taking about the memory orientation. Okay, that memory and that memory is in fact distributed. That means the same file is available at multiple locations with the help of the replication. And of course, many machines can access that particular data. And if something happened to any of the data node, of course, name node is having the information about which are all the contents related to that data node. So simply by using that metadata information, one can attach a new data node and they can follow. Coming to the MapReduce orientation, which is a typical processing engine, guys. Okay, that particular processing engine basically helps us so as to run the jobs in parallel. Now you can also see map and reduce also completed, map and reduce. So it is giving some kind of information. So similar thing, no matter whether you are running your job in the cluster or whether you are running your job in your virtual machine, in either of the case, the activity is same. But only the thing is maybe timing wise, the live cluster give you the best optimizations. Like it won't take much time, I can say, and you can also observe that it is taking some pauses as the resources are very limited. No? So just while creating the virtual machine, we need to specify this is the hard disk I am allocating to you, and this is the RAM capacity you can make use like that. Otherwise, see the file system counters and as well as the job counter launched and framework activities and finally the shuffle and all these kind of things are as usual. Okay, and it is giving us after completion of this thing, okay, as how our cluster is giving us the job is completed successfully. Now just you observe this in the above command OU1. Okay, OU1 is our output, one is our MapReduce outcome. So let us see how it is generated the outcome. Hadoop FS-ls. See, it is taking some pause and then only it is giving. Because there you can clearly see, friends, how local file system and distributed file system are taking some time. In local file system, if I am giving ls, immediately it is giving the outcome. Okay, whereas in Hadoop, just it is taking a pause and then only it is giving us the outcome. Now Hadoop FS-ls, just the output one is available, OU1 slash. Just you can observe part 0, part 1, like that it is going to display. That is a general convention. So even while working with your Spark or while working with any other kind of the Hive or Piglatin, if you see the files in terms of part hyphen 0 like that, then it is belonging to Hadoop output friends, MapReduce output especially. Now, similar to this, just I want to understand how many resources were there in our project. Okay, so as to evaluate in front of the client. So just I can see Hadoop FS-cat, the corresponding output folder and the file information. Okay, So the point here is, friends, no matter whether you are working with AWS, Azure, or GCP kind of thing, or even in your virtual machine also, the context is same. That's what intentionally I pull this particular demonstration on the virtual machine, which I am having in my machine. So this is a virtual machine where I installed all the components and I configured manually and all. But due to the limited resources of the machine, it is taking some time so as to replicate. Whereas if you give ls, it is immediately given. But whereas if you go through the Hadoop command orientation, just it is taking a path. There itself you can clearly observe. It has to contact the Hadoop and then only master. There are certain services. No? First it has to contact the master, then only we will be getting the outcome. But in case of the LS, there is no master slave kind of thing. Simply that is a Linux environment. Directly we can able to get the outcome. Okay. Now there are certain situations, friends, where in this case, as a Hadoop developer, as a Hadoop expert, you have taken the decision of okay creating the jar file and making use of your Hadoop input file and performing some kind of activity by exporting the uh, mapper reducer and driver class as the .jar file. But this may not be the case every time, because if you are having enough Java developers in our team and maybe they are giving us some kind of the coding, then in that particular case, they may give you some kind of, they may give you some kind of jar file only things. So in that case, my question is, if they are giving you the code, then you can easily observe what is the package name, what is the class name, and what is the driver class name, mapper, reducer, all these things you will be knowing. But let me talk about this one. Again, we are moving back to our favorite cluster, and just I want to connect this thing. Now you see, friends, what is the distinction? So immediately it is giving us the thing. Okay. Now I'm having certain um, MapReduce jar. This much I'm having, friends. Only this is I'm having. And they asked us, okay, you can make use of this jar file and submit the job. That much they said. So even we don't know what exactly the input and which are all the class name, driver class name we should know na, at least. Of course, up to some extent only we know. Hadoop jar, MapReduce 5 dot jar. Up to that only I am knowing. But whereas my understanding is how do I get the package name? How do I get the driver class name? So what is the in what way I can interact with this thing? For that, friends, just have a look on this. There is one approach for that. Though you are having some certain jar file names, but there is a process how you can interact with this particular jar file information. Okay, so just I am making use of MapReduce 5.jar. Only we are having that information. For that, friend, just I am having a command called unzip -l, and you can give MapReduce 5.jar. Simple. Now you see, automatically it is giving some metadata information. That metadata is our requirement is this is the map class, this is the reduce class, this is the actual word count class. And of course, that particular class is again mentioned in uh, form.example. This is the package. So, see, the advantage of this particular command unzip is just we can even the Java developer gives you the jar file name. We need not worry. We need not contact him personally, or you need not ask him like what is the driver class name or package name I have used. No need, friends. Simply just to, as you are having the jar information, just you can make use of the unzip. Okay, unzip of -l, and just to mention the MapReduce 5.jar, then we will be getting all the information. With this, one more thing, just within the Hue login portal, I'm having some kind of input with me. That is the email input actually. So The email input I have taken from external machine because some context is like this. Friend. This email input is something like all the members are writing to the managers actually. Okay, some people are writing some kind of complaints or appraisals or what is their experience of this particular products. Maybe I'm having that information in the email input. Now, what I'm doing here is I want to make use of this email input. Okay, so this email input is not a single liner or single word. Many words are there. So what I want to do is I want to apply some word count logic. So maybe any negative words are there. Okay, the worst or something like we are not satisfied, so that we can see how many members were satisfied, how many are not. Okay, so that the manager can conclude that we are going in a proper direction. Or if so much negative comments we are getting, or so many complaints we are getting through this outcome, then manager has to take the decision, like whether I need to change the flow or is there any modifications required. All these kind of the conventions. Okay, this is a typical emailing communication which we have allowed to the customers. Okay, so just the customer can directly contact, even in some kind of cases, friends. Maybe while learning in many LMS platforms or in many e-commerce websites also. After delivery of the product also, you will be allowed to share your, whatever the feedback you want to give or what is the quality of that thing. Even simple Zomato or Swiggy also, they ask us some kind of communication or feedback. So how is the packaging? How is the items? And out of four items you ordered, you can individually give the feedback. Suppose if some of the items are not good as per the expectation, you can directly specify that. So in this way, just we are having some kind of a scenario, and we want to make use of this particular scenario so as to understand whether we are in a proper direction or not. So for that, just we are taking this email input actually. So let us see how this email input helps us. Hadoop FS-ls. I'm having this email in. Okay, this is the input file I want to give. And just now, as said, MapReduce 5.0 is my requirement. And within that MapReduce 5, the unzipping. Actually, just we have unzipped that particular file, unzip-l jar file. Then it has revealed all the internal information, okay, the metadata information about this particular jar file. So I can make use of this thing. Okay, now let us see, friends, how we can do that. Let me clear the screen. So just we are making use of email input and all these kind of the conventions. So just sometimes it is taking a pause as a of our virtual machine. So unzip -l MapReduce 5.0. This information we need. Of course, this is enough because email input we are having we know the name Hadoop. The jar file I'm giving as MapReduce 5.jar. And then I should specify the package name dot driver class. If you see the one, two, three, fourth row, friends, here. This is the fourth row actually. This fourth row. What you need to do is just you have to mention the package name dot class name. Here also W caps and count caps. The typical Java kind of thing. And thereafter I am giving the email input. And output I am taking MR output. So just I am taking MR underscore Java 1. Okay, some reference. Maybe my MapReduce job may be taking sometimes Python orientation, sometimes I'm taking the Java orientation. So just for the sake of identification, just we are taking this approach also. Okay, right. Just to do this. We need not wait that much, guys. Immediately, this live cluster helping us, and even that virtual machine also reasonably done well, friends. Even this thing also taking pause and because they are all parallel now. It has to collect the information. The master is there, and every time the slave should update the status information, and maybe sometimes the appropriate data node may not uh, available. So in all those cases, internally we have some kind of architecture. Okay. Now, yesterday we have seen some kind of speculative execution, which is excellent topic. No? So especially while running the job, if something happened to that particular job, if any problem is there for the specific task tracker, then the job tracker has to establish a new task tracker so as to continue the job, okay, without any wait. In that particular case, we have seen some interesting scenarios that time. The scenario is pretty simple, like suppose if the old task tracker, which failed earlier, if it also responding back, it is also trying to respond back. So in that particular case, just we need to have a look on that. Okay, so just both the tasks are on track and both the tasks are responding back, but it's not a optimized idea. It's not a good idea by the job tracker to keep both the tasks. Okay, so just it has to estimate the corresponding status information, and then it goes with the corresponding task which has done reasonably well and which has given the status more higher status information. Okay, so that is the idea that we have seen. Now see here, just as in case of the virtual machine, how we have seen, no matter whether it is a Java program or Python context, in both the cases, this information will be getting actually. All this kind of information we are getting. Now, just if you refer this kind of the convention, and if you consider the outcome, that is MR underscore Java 1, always the good idea is just go back. Here we don't have MR underscore Java 1, just you can refresh this, refresh the new login portal, and then it will be reflecting. Okay, still today it is generally since this weekends they are in under the maintenance process actually. So maybe today may not be weekend at US, but that's how Saturday and Sunday, if I'm interacting with these particular cluster, it is under it. It takes more time. Sometimes they stop the name node also. Okay, so it all depends on the provider. Now the Java one, just to click on this, the partition information, and we have given this data frame actually, email data, which is reasonably large. Okay, this information, and the manager can observe whatever the data they got. Okay, so more data if this thing is some of the things are very high, maybe this is the area or something. Okay, so just they can make use of the kind of the convention. Okay, so this is how you can submit your job postings, both in case of the Java and as well as the Python orientation. How you can easily compare, easily observe okay how the native Java code can be helping and even without knowing your driver name or mapper and reducer by simply getting the jar file also from the Java developers you can make use of that convention. Now let me show you some other directions. So this 1 minute guys. Okay, so hmm, 1 minute guys. This is yeah. Hmm, not my account. So just a minute. No problem. I'll get back that in a minute. So again, I have to see how I can make use of this convention. Just a second, guys. So in between, just you can observe the distinction between Java orientation and Python orientation. I thought of showing you some. Yeah, I'm having, however, this now. Okay, so here also access denied. Take me to home. 1 minute. Mm. See, as I said, maybe they undermade. Ah, yeah, got it. Yes. Sorry for the interruption, guys. Okay, so just you can see the initial page. Just I'm having this Cloudera manager. Click on that. First time, however, it has to launch, no? So just it takes some time. Within this Cloudera manager, if you remember, guys, in the day one, we have seen some configurations of that. Now, I want to show you how the ad looks like, because now the immediate topic we are going to talk about is limitations of the MapReduce II and ad. So Hadoop distributed file system, and now we are in the map. Actually, one simple thing is, though I have not introduced you the ARN or MapReduce II, but logically we were using the job submission and all the things in ARN frames. Okay, so just let me show you that convention as we are using the latest Hadoop. So just it is connecting to resource manager. Okay, and it is establishing the ARN application. So indirectly, we are using that thing, but we are studying that MapReduce one architecture. No? So as to compensate that kind of the convention, we need to understand what is the distinction, in what way we can specify the observation of AR kind of the aspect. And if you keenly observe, AR MR2 included. Okay, MR2 included. So just you can see the, just to click on this. There are certain observations and here, job history server, node manager, resource manager. Slowly we are seeing the context or the relativity of this array. Okay. So as already we have seen, the resource manager is a kind of entry where is the which is performing the activities of the job tracker. A node manager is something like which is similar to our task tracker. Okay, that's what we are having 5 task trackers and one resource manager because this is a master. Resource manager or job tracker is a master. All the 6 are good, having the good health. Okay, just you can observe that. And most importantly, we are having the web interface actually. Just to click on the history server. Click on the history server, it is not going through. So go back to this and you copy the, just to copy here and until this colon, what you can do is just you can paste this server because from that we are contact, no? We are getting the contact. So just to click on that. Then it leads you to the communication of the job history. If you observe friends, this is our username actually, big data mind one assigned to us. And this is the actual job ID. Okay, if you observe the job ID of earlier example, this is the job ID and which is giving the submit time, start time of the job, finish time. Now, the name of this job, okay, practically even we are not knowing the internals, but with the help of the driver class name, with the help of that unzip of that RAR file, we have seen this thing. And this was like that, many other users would be there, friends, maybe other users also, because this is a distributed cluster. It's not a dedicated instance, as I said. So the job status is succeeded, and then we are having the number of maps completed, number of reducers completed, and elapsed time. Okay. So if you want to understand, okay, this is of course we came to this place with the help of the air only, if you remember. Okay, we have clicked on that the corresponding ad, and within that I am having the web user interface, which I'm where I'm having the history web server and within that history web server, all the entries related to my job were available. Now we click on this guys. Okay, to give a glance. However, after completion of the MapReduce one limitations and after going through this job, I mean, ARN and all, Again, we'll be seeing these kind of the conventions. Now you observe this here. The job name, username, submitted, and all the state status information, every information, map time, shuffle time, see, merge time and reduce time, all these kind of the things you can see. So as to estimate the information, how many number of maps are there, how many number of reducers are there. Okay, is there any failed jobs or killed job? All these kind of the conventions can be observed. And one more thing, just you can see the specifically some map tasks. Okay, how many map tasks are there internally? Because if you observe, friends, it is not directly running map 25%, map 50%. Like that, our map reduce job generated two tasks actually. Okay, this is the map one and map two. And reduce tasks also, five reduce tasks it has taken. Okay, so as to complete the task. So all these particular five reduce tasks. And the point here is, friends, maybe due to some reason, this reducer two is not functioning. Here it gives the failure message. Immediately, instead of this particular thing, maybe the resource manager established one more task named as five or something, reduce five or something. Okay. So, like how many tasks, how many submissions we're having, though you have submitted only one job, but related to that particular job, we are having many informations. Okay, two map tasks, and if any problem is there for either of the map, then we can easily track that and even reduce tasks also. Even Hadoop admin activity is this one only. Suppose after the stipulated time also, if you are not getting the response from the job, then he can simply go to this history server and he can verify all these kind of the functionality. So the job history, which gives you the completed job information, and there you can see how many map tasks are there, how many reduced tasks are there, and how much time they are taking. And sometimes, guys, maybe a particular map or particular reducer may be taking extra time compared with other things. Though load balancing we follow and all. So in that case, something we have to do. Some optimization techniques, all these kind of the considerations you can observe. So as a part of that optimizations, we are having certain best practices. Okay, that in a while we are going to talk about these kind of the conventions. So the flow is just we are going in a flow. Like as of now, just we have seen some Hadoop distributed file system and map reduce pages, understanding of the job tracker and task tracker functionality, submission of the job with Python context, submission of the job with the Java context. In either of the context, just we are, as we are using Hadoop 3, just in both the cases, we are submitting our job to the YARN cluster, and there we are making use of the resource manager and as well as the node manager. That convention we have seen. And as a part of understanding this particular YARN, technically we have seen this Cloudera manager, and from this Cloudera manager, we picked up this YARN that tool from that particular Cloudera manager. And within this, we can able to see the history server environment. Maybe you're curious about what is this resource manager. Okay, the same convention. So just you can copy that info, whatever the server name we are having. It gives the currently running jobs, friends. Okay, so the active jobs. Okay, active jobs. See, someone submitted the Spark because, as I said earlier, no, ARN is not only helping us to submit the uh, Hadoop or MapReduce job, it also helps us to submit the Spark. Okay, so now earlier we have submitted this job, friends. This is also there. This is our submission actually, and this is the type of MapReduce job. Whereas someone, okay, so some other member submitted the Spark based kind of result so that it is containing that application type. So just to click on this job ID, same 11212, click on this. It's not currently running, but of course you can observe some information related to this. Okay, attempt ID and start ID, more or less the same kind of the convention. But here you can verify your Spark jobs also. Okay, so all the finished jobs. Suppose if you want to know about the running jobs, which are all the jobs running. Okay, currently we have not submitted anything from our user, so it won't show anything. So, but some other user may be submitting to this particular cluster. So you can see that currently running jobs, these things. And the current running job information can be verified. Okay, whatever the job running and what is the status. Okay, so as of now, just to observe that, friends here, in the initial steps of the ad, we understood that. So let me share the note, one note, so that you can also have a look on this particular thing, right? Okay. Now what you can observe here is just I am making use of the convention, like some of the terms are related to our ad. Okay. So the very first point we observed, all the job submissions, okay, all the job submissions may be Python or Java in either of the case. Um, in Hadoop 3 will be handled by um, add will be handled by add. Second one, so add assigns job ID and launches resource manager. Okay, launches resource manager. I have not yet introduced, but let us figure out which are all the infrastructure we are having before starting of the ad. In coming to the third point, in the Cloudera manager, you can see add MR2 included, add MR2 included. So this is the other point, and if we select add, then within the web UI, we are having two things. One is the resource manager. Second is the history job server, job history server or history job server. So coming to the first one, your resource manager gives the information about the Spark jobs, MapReduce jobs in both the ways, and which is also giving the running jobs information, completed jobs information, failed jobs, all these kind of the content. Okay, and the second point is from that we're having history job server. So here guys, we're having a job ID and the corresponding username. These things we'll be getting. And apart from that, we'll be seeing the map info and how many map tasks are there. In our example, we have seen two map tasks, map task 1 and map task 2, and the time taken to run that particular map task. Similarly, we are having the reduce task, reduce info. Especially in our example, we have seen five map tasks, five reduce tasks. So as to complete our task, it has taken five reducers. Okay. So like that, you can observe. And apart from that, what is the point? Fifth five. Okay. The fifth point we observed. If you remember, friends, within that ad, if you click, we are having the resource manager, node manager. And one more thing we have seen that job history, uh, job history server. Of course, resource manager one, these node managers equivalent to the data nodes. This is the slave kind of thing. Okay. So with this, just we can we are having all the information with us to jump start with the ARN orientation. Okay. I'm pausing here, guys. I'm taking a pause here. If you are having any doubts, please let me know. Meantime, let me paste this info with you, which are all the map tasks, so that you can also have a understanding logically your map tasks and all those things. Just a second, guys. So it is quite interesting because the people who practice these kind of the conventions always having the observation of these tools. Many tools are there. So, second. This is the map task information I have pasted in the chat. And similarly, let me paste the reduce task. So just that particular reduce task also giving us a kind of convention. Mm, So we pick up that this is the reduce task. This is giving the information about all the number of reducers we have used. This is the second convention. And going a little ahead, initially we are having the status info of the ad, where it is providing us the info of resource manager, node manager, all these kind of the things. Just you can observe if you see this convention, because I want to empower you with all these kind of the conventions, all these nodes actually, all the nodes which are available. And thereafter, initial point in time, after selection of this thing, one just we are after selection of first time, if I'm selecting add, it is taking us some other zoner. Mm, yeah, that already I have pasted. Okay, right. So these are all the major conventions related to the understanding of the ad. Okay, map task, reduce task. Yeah, one more thing, right? That is that one is there now. Whereas our this thing, resource manager portal, that is also there. Let me give that because we have seen these things are nothing but a history server. Now I am having the resource manager portal also. That also you can see.
Excuse me, sir. I think you are on different screen.
What is that? I'm sorry. I'm not
You
getting you guys.
you
Vedant?
you are on
No.
the Windows notebook screen. One note screen.
Okay. No problem. Let me share that. Yeah, that's what even I'm pasting in the chat so that you can
Okay, okay.
access. Hope you can see,
Right.
no? Yeah. No problem. That's fine. Vedant, thank
Yeah,
you.
yeah, now it's visible.
Okay.
Right.
These you can see, guys. Okay. So this is all
Yeah.
because the point, friends, here, in case of your map and reducer or this history server, hardly it gives the tasks only. But your this resource manager, because we are going to talk about that thing actually. If you see this web UI, even I have to give this thing also to you 1 minute. Because these terminologies are most important. Within the resource manager, I'm having this convention actually. So the resource manager and as well as the history web server. Just you can make use of this convention. Because these terms now we are going to talk. Now, let me ask you this question, friends. Before launching the ARN and all the MapReduce one problems and all, just I want to ask you some two important points. The very first point is simple. Um, Suppose I'm having some data with me, mm, like the data is Hadoop, Hive, Hive, HBase, Scoop, Scala, Scala, Hive, Hadoop. This is the data I'm having. Assume that after split, I'm having this data. So that means we're having multiple records, all these kind of the conventions. Now this will be given to your map phase. Just what it does, just it is picking up all those particular data items, is making use of Hadoop 1, Hive 1, again Hive 1, HBase 1, Hadoop 1, Scala 1. Again, I'm having the another resource Scala. Uh, Now here also Scoop 1, Hive 1, Hadoop 1. Just I'm having this convention. Now, if you observe this thing, friends, after that, the shuffle phase, now the point is, though I'm having the repeated Hadoop here, so this is the repeated word. I've repeated here, hope many times repeated, Scala many times repeated. But in the general consideration, though repeats are there, but still these repeats are not going to aggregate. They were not going to aggregate, and these particular repeats should be carried from mapper to shuffle, shuffle to reducer. Now, what is your analogy? Suppose if there is any aggregation, just I'm asking guys, if there any aggregation, rather than keeping these particular same kind of the words, okay, rather what I can say is Hive I am having like this. Whether this is better or else here itself, if I'm combining and then if I want to traverse out of these two, which one is better, friends, and why? Think through in the network point of view, not in the Hadoop or big data kind of the perspective. Just I'm having some stream of the data or some kind of the input data, like I'm having Hive 1, Hive 1, Hive 1 like that. Whether to send these particular three messages or whether sending one message is optimized or whether sending three messages is optimized. Which one do you prefer then?
Second one.
Third, second one.
Second one always. The reason is because I'm using some bandwidth here. Okay, in the network, in a typical network, I should reserve for three votes actually. Vote one, vote two, vote three. Logically speaking, in front of the network, I'm using only one vote in the second scenario. This is the first scenario. This is the second scenario. Now, in a typical Twitter or any e-commerce kind of the application, we'll be getting the feedback in the repeated mode, friends. Repeated mode. Okay. So it is always the club. In this case, I'm using only three Hive repetitions. But see here, we got rating for a particular product as excellent by 10,000 members, assume by 10,000 members. If at all I'm using the word count application, and my word count should carry these excellent one until 10,000 times. Rather, what I can do is I can fix up, I can aggregate these things at a certain point of time, and I can directly transmit this thing in front of the network. Rather than sending this thing, it is always better. Okay, this is always discouraged. So, but how do you handle this convention? There is a convention called combiner. Combiner is also known as local reducer. Local reducer. Let me pick a image frames from net. So just a minute. Combiner logic I will be giving to you. Uh, Combiner in MapReduce. Example. So just I'll be taking some image for you. Yes, got it. Okay. Thanks to Google. Okay. So now have a look on this, guys. Maybe a little blur, no? Okay, let me pick up one more. Uh, that is excellent image, guys, by the way. Combiner logic. Mm, 1 minute. Because that particular combiner logic, what I am mentioning, that really gives you the pleasure of simplifying the things. Simplifying in the sense, just we need to mention that combiner logic. In Java, guys, this is only one statement we need to add. One statement. But in Python, we have to write separate combiner. So we will go ahead with this thing only. So this is combination or else. mm, this is here. One more thing I got actually, but that it's okay. Yeah, this is bit better. Okay, now have a look on this, guys. Just you, if you see this, mm, so we are not waiting until now. I need to paste the normal map reduce also, na? Excuse me. So normal map reduce because I should compare both the things. Reduce example. Uh, Click map. Okay, this thing I'll be taking. Right. Mm, okay, and then eh, they're not fixed then. So it's okay. Right. Okay. Now just have a look on these two things. How we are seeing the typical. This is also fine. Just I can make a note here. This is a normal map reduce process. Okay, normal map reduce process. Though I'm having the repetitions, here I'm having the repetition here and here, here and here, and here also we are having the repetitions. So though I'm having the repetition until the reduce phase, I have to keep all these particular whatever the data items I'm having. So it has to traverse all the way. Okay, it has to traverse all the way. So reduce phase, until the reduce phase, there is no chance of aggregating these things. Okay, there is no chance of aggregating these things. So the drawback here is with the normal map reduce. Okay, so the network bandwidth usage is high. High means okay, no problem, but unnecessarily we are, even for repetitions also. Repeats also consuming the higher bandwidth. Okay, without aggregation, what we are doing, simply we are making use of the same statements, same words again and again, and in a way it is consuming higher network bandwidth. But in this case, just to have a look on this thing, this way I'm using the combiner. Actually, this is the logic, combiner logic, and your combiner logic is a local reducer. Actually, I would say is a local reducer. And what it does is, friends, rather than waiting until the appropriate reducer, just you can see here, of course, here we don't have any repetitions. It performs as it is. But here we do have the repetitions. It has taken here only. And here these also have the repetition. So before launching the shuffle phase, before launching the shuffle phase, one can able to uh, one can able to aggregate here only just by specifying the combiner logic. Now observe here, guys. One more point here you need to observe very clearly. From this particular example, this word is having one in the first block, but whereas in the second block we are having two such. So what it does is, it is not disturbing the flow, friends. Actually, what it does is, it is aggregating and it is combining. Okay, first block is one, second block is two. Suppose Hadoop, in the first block I am having the three repetitions. In the third block I am maybe having the five repetitions. So even in that case also, okay, just observe here, guys. In both the cases, as don't feel that directly I am shuffling here only. That is a wrong understanding, guys. We are not doing any shuffle here. Only the thing is, if the current block, if the current block is having the repetition, then only we are making use of the aggregations. Then only we are making use of the aggregations. Of course, there is a separate phase, guys. Actually, shuffle and sort phase is there. No? There is a separate phase where this particular phase helps us to uh, aggregate all these things. In a way, it is shuffling all the relevant words, and by the in that particular shuffling, however, it is allowing the aggregation there itself. That is understanding how a combiner logic acts as a local reducer. Of course, in the reduce phase, again, the final aggregation should be there. But what we are doing here with the help of the combiner logic is temporarily, if any kind of the word is repeating many times, rather than exclusively using that network bandwidth for the same kind of the transmission of the data, it is always better to make use of the combiner logic. Okay, so but don't mess with the combiner and shuffle. Uh, hope you understand my intent, friends, because combiner is not having the capacity of the shuffle. It is only having the capability of whatever that block information, and it is going to make use of the aggregation of that block. But it is not having any I mean, consideration of shuffling or sorting or something. Still, the framework activity, shuffling and sorting won't be disturbed by the combiner. Only the combiner's activity is so as to pick up the individual blocks. And by chance, if that particular block is any repetition, then obviously we are going to make use of the combiner. That is a local revision. Now our purpose is survived here. Okay. So this rather than using all these different kinds of the words multiple times in the same block, uh, just there is a possibility of using the combiner. Okay. And one more question I want to ask you guys here. Suppose I'm having some scenario like this. I'm having some data like this, guys. Okay, so Hadoop, high HBase, and thereafter I'll be having some Scala, PySpark, Databricks, MLlib, like that I'm having the data. Now my interest is I need to segregate the DE technologies, like all my DE, Hadoop, Hive, HBase, all these things into the data engineering perspective. All my data science, like maybe Scala I can use, PySpark I can use, MLlib I can use, all these things. Maybe Databricks is a platform. Okay, so no problem. Just to not consider, this is not a tool, is a platform. So just if you refer Scala, PySpark, and MLlib into DS. Now my idea is whatever the data I'm having, I want to segregate though I want to partition or I want to segregate those particular data into the sub data items. Okay, based on some condition, like how I specified here, DE batch, Hadoop Hive HBase projects and DS projects. The client demands Scala, PySpark, and MLA. So to cope up with these kind of the conventions, I'm having a logic called partitioner logic, friends. Okay, so what that particular partitioner logic is, the partitioner logic basically gives us, so just it is going to apply some kind of condition, and based on that particular condition, one can specify the outcome. Okay, so just I'm pasting here, friends. This particular image is containing both combiner and as well as the partitioner. Okay, so which is giving us some kind of the information. Now you have a look on this, friends. The partitioning logic. Uh, Here, the partition logic basically split or basically separate the appropriate information into a separate partition. Maybe all car data I want to place in one partition, all the river data I want to place in some partition. But whereas in the earlier example, if you see here, okay, so if you talk about this kind of thing, there is no separation actually. There is no separation. Obviously, it is going to place directly. But your partition logic, further it applies some kind of the condition, and that particular condition helps us so as to convey, so as to apply some kind of the specifications by the user. So here the partition helps us so as to route the appropriate information, and according to that particular routing, we can able to perform the activity. Okay, so this is how you observe your understanding of MapReduce orientation. And apart from that, your MapReduce is still containing the other some other functionalities also. Okay, let me give you the overview of the key takeaways of the session before taking a break. So the key takeaways of the session. The very first thing we have seen, the Java job submission to Hadoop cluster. Hadoop cluster. There we have seen two important considerations. One is you are having the source code. Source code involves three things, my friends. Um, One is mapper class. Second is the reducer class. Third is your driver class. Okay. So in this case, you can export jar file. You can export the jar file. The second consideration we have seen, if we only having dot jar file. Sometimes it happens, friends, because And I think we are not going to do anything with Java code or Python code. Now, our intention is to pick up that code and submit to our Hadoop cluster, and we should send a report to the corresponding cluster maintenance or to the client. Okay, how much resources we are consuming, or whether we are okay with this cycle, or whether these consumptions are causing any uh, cost implications, some kind of the analysis, right? Okay. So if you are only having the .jar file, then what we need to do? Just I'm making use of command unzip -l the .jar file name. So here what it is listing is, it lists out certain points, friends. First, it is going to give your mapper class, reducer class, and maybe if you are having some package name, okay, in this way it refers com slash sample slash driver class. Like this is nothing but the meta information, metadata actually. Okay. From this, I can pick up the appropriate package name and all the corresponding things. Okay, these two conventions, and in the job submission, okay, to submit Java-based MR job. Okay, we identified this convention. Um, Hadoop jar. This is user defined or user exported jar, friends. User defined jar. And next we need to give the package name dot driver class name. Uh, Along with that, no need to mention any hyphen input or something. Directly input file, output directory. Okay. So now you have a look on this way. Just you can take the example. So I'm giving the repetition. It's okay. You need to observe this point very clearly. Hadoop jar. We have taken mr1 dot jar, mr1 dot jar, and thereafter what we are doing is here just I am mentioning the package name dot class name. And package name, for example, com dot sample is the package name, and I can mention this driver class name also. What is the driver class name? Just we have taken word count, and I have mentioned this as email input. Assume that email input, and my output is mr1 underscore jar. A pretty simple narration. So let me give you this insight also, friends. Suppose if I am giving a directory of input rather than a single file. Okay, hope you got the point, friends. Let me go through the workspace. Let me share the screen once again. Just a second, guys. So what I'm doing here is just I'm now having the virtual machine. Just I'm clearing the screen. Hadoop FS from LS. It is taking some time, no problem. Okay, so my thought process here is I want to place some kind of the input data, whatever the input data I'm having, ex1.csv or 1.txt into Hadoop fs -mkdir uh, mr input. I'm creating a directory. Within that mr input, I want to copy some kind of the files. some input.txt or one.txt, like that multiple files I want to place. And I wish to give this directory instead, because generally in the earlier examples also, we have seen the usage of files only. Now what I'm doing here is Hadoop fs hyphen put also I can use, no, rather than copy from local x1.csv to uh, mr input slash uh, ex1 that I'm taking. Ex1 is one file, and thereafter I want to copy the input.txt also and one.txt also. Multiple files will see. So within the same directory, I'm having the multiple input files. So this input directory I'll give as the submission. This is done. What I'm taking Hadoop fs hyphen put. Just this time I'm taking the input.txt. I want to copy into mr input slash ex2, maybe some other name. Okay, so easily you can see. Okay, within the mr input directory, I'm having the example one, example two. Later we'll see the one.txt also. Okay, that also will copy as ex3. So our mr input is having three different files, and we'll try to give this as the input directory in our job submission. So same thing, span one.txt, and I'm making use of ex3, the same put command. Now will all the example one, two, three, all the source files are there in the mr input, and we'll try to run the uh, job submission, okay, related to that particular file. Of course, it takes some time. Meantime, we can finish that key takeaways. Okay, some more points are there. So just you can see here, Hadoop fs hyphen ls mr input slash. I should see ex1, 2, 3, all these things. Mm, so mr1.jar is there. Within that mr1.jar, I am going to make use of, yeah, all these three files were there. Now Hadoop jar, my jar file is mr1.jar, and I am making use of the same program, word count, the same thing. And this time I am giving the input as mr underscore input, and I want to store in mr underscore output. This is fine. MR output is fine. Every time we used to do that. But I want to see if I am submitting the MR input, whether it is integrating all those three files or not. That is my idea. Just if you see that, whether it is reacting to us or whether it is going ahead, let us have a look on that. Okay. Just we are placing all our input files. Sometimes it happens, maybe I'm having from different departments, I'm getting some different input data items, and I want to aggregate all those kind of things. Of course, it is taking, see the number of paths. So earlier, maybe it is number of paths, maybe one. This time it is taking three, because three different inputs are there. No? Definitely, my mappers also raise. So according to the input data item, it is going to elect the corresponding mapper. According to your mappers, the reducers will be decided. So there is no harm, nothing, no problem. You need not give every time only a single filer. Unlike the earlier examples, maybe you can take the directory. Of course, that particular directory may be containing some multiple input files also. It's absolutely fine. There is no problem at all. Okay, but only the thing is it may need to launch some extra mass as based on that splits and all those kind of the conventions, and it the process follows as usual things without any hassle. Okay. Now let us go back to our discussion. Once that is over, just we'll be back and see. Um, Now what I can do is just to fulfill this scenario, yes, of course, we can do place all the input files into a directory, and this directory can be used as the input parameter in the job submission. Okay, now friends, input parameter in the job submission. Now, example also we take while preparing. You should not feel any difficulty. Hadoop jar mr1.jar. Next, I should give the package name dot class name. No? So com dot sample dot driver. Assume that we are giving the word com. After that, here I am mentioning the directory actually. So the directory I have created mr1 underscore input directory. This is a directory which is having the files of ex1, ex2, ex3. All the files I'm having, and I'm giving the mr underscore output. This is as usual, friend. This is nothing new to us. So the possibility here is whatever the code, whatever the individual input files I'm having, all those input files can be packed into a directory, and that can be supplied as the input. That can be given as the input reference to the Hadoop jar submission, Hadoop job submission. So these things we have observed. And once this talk is over, we have observed number. Yeah, first thing only. No? First only we are discussing. Now I introduced this second point in front of you. This is the second point. Now coming to the third point, we have seen some combiner logic. Is a big local reducer kind of thing. So which helps the aggregation of repeated, okay, no? Aggregation of the repeated rows, uh, aggregation of the repeated rows within the block so as to optimize the data transmission over the network in the job processing or in the job running. So this thing you can observe as a combiner logic. Fourth point we have seen the partition logic actually. Partition logic. If you want to reroute, if you want to route the output based on some condition, then uh, we can make use of make use of partition logic. Okay, this thing we observed in the combiner and partition. Thereafter, while launching the job, we have seen from Cloudera manager. Probably after the break, we are going to discuss about this ad Cloudera manager. Within that, I'm having ARN component MR2 included, and there if I am clicking that ARN2 add MR2, then I will be leading to this thing actually. A resource manager, node manager, and job history server. So these three components we have seen. And one more important point, in the same thing in the web UI, we are having two things. One is the resource manager component. Second is the history server. So these things we have observed in the Cloudera manager and especially. Now we'll go back to the execution. Oh, still it is taking, yeah, 50 and because multiple things we have given now, guys. That is the thing. Just it is taking much time. Okay, no problem. But I could have used this our cluster actually rather this thing. So and connect. I can make use of this cluster. So by providing multiple input files, let me see. I'm having the cloud connected with this. Yeah, I'm having this one. Let me clear. So Hadoop FS -ls. Mm, there is a directory I'm having. D or DS I'm having. Let me see. Which are all the files I'm having. D slash. Yeah, some files are there, guys. So what I can do is just I can make use of this information so as to submit my job. So how can I do? Hadoop jar. The job is MapReduce 5 dot jar. Hadoop jar uh, and before that 1 minute, guys. One more shell I need to have. So big data mind one, big data mind one and plan. Okay. Now what I am doing here is I need to unzip this file, unzip -l MapReduce 5.jar. This information I need and DE folder directly I will use. Okay, so com.example.word count. What should I give? Hadoop jar MapReduce 5.jar. From this you can see I'm having the com.example dot. So com.example dot. What is the file name? That is word count. Okay, wcats word count. And directly I'm giving the DE. Just now we have seen the DE folder containing some information and MR job, MR job DE. So some kind of the reference I have given. So because this is bit faster compared with that one, that's what we have selected without any hassle, without any complaint. It has started. Just it is making use of C. Total input files 5. It is clearly mentioning that. Let us see how many maps it is going to establish. Uh, so as to verify, because currently we are running this 11243. Directly I can go to my this portal. Okay, whatever the portal I'm having, just you can see here. Now you see the currently running jobs, friends. What is my current running job? 11243. I can see here 11243. Just it is launching that. So currently we are running this one. Okay, 11243. Here live you can see, friends. In the live manner, how many? Currently only one attempt we have done. So is there any finished jobs are there related to our 1143? Yeah, it has finished actually. 11243. So such a faster thing. And if I want to identify how many mappers, how many reducers are there, so because this is the older one, just you can see go back. Okay, so go back to this and history server information I can get job history and again go back. This is the older job. So just now we have launched 11243 that ID. Okay, so I want to know how many maps were there, how many this thing were there like that. Okay. This is earlier. Again, I should go back because map reduce all those things. Yeah. Just to refresh this job history because that is yeah. Now it is reflected there here. Level 1 to 4. Click on this. Okay, so there are certain map tasks. Let me see how many map tasks are there. Yes, friends. This time 5 map tasks are there. This time 5 map tasks. And reduce task, is there any update? Earlier 5 we are having. This time also 5. That means your map tasks are influenced by your number of inputs. Okay, because in the earlier, if you see the earlier job, just go back. And if you move back to earlier job, this is also our job only. Just to click on this. And if you see the map tasks, it is only 2. It is only 2. But whereas in the recent job, okay, whatever the current just completed job, we are having the map tasks and more map tasks are required corresponding to the input data. Okay, so that is how you should have not even 5 actually six are there. Okay, 0, 1, 2, 3, 4, 5. Now, if you want to understand how my um output is looking like, so for that we need to connect the Hue login portal. So with that Hue login portal, you can have a look on how these because sales is one file and HDFS 100 is another file. Okay, like that I'm having multiple files with me. What is my output I have given here? MR, where is that? MR job underscore D. So just you can go through here. Uh, just to refresh friends, all these things can be observed and D. Your job is MR job underscore D. Click on this. See, part 0. Maybe some of the file. It has taken some purchases data or something. And then it has taken some other example, same purchases, because that is a bigger file. Okay, like that it is going to apply all these kind of the conventions. So that there is no harm, friends. You can make use of all the input file information, and accordingly your Hadoop cluster. Okay, that job is performing accordingly. Let us see how where we are in this thing. Yeah, here also completed successfully, and all the ex1, ex2, ex3 files are combined. And as the output, just we have seen the output as MR underscore output. Okay, so clear. Just I can make use of Hadoop FS Python ls MR underscore output slash. So obviously, some more partitions would be there uh, according to the inputs we have given. Sometimes it is combining all those things. It all depends on the memory availability things. So within the same data node, if I'm having all the memory available, then no problem. Directly it is going to, yeah. See, here, though I'm giving the multiple inputs, still I got the same partition. But in our this example, if you see this example, I'm having multiple partitions. It all depends on the number of inputs. It all depends on the number of inputs. If your input, though multiple inputs we are having, but your input is very simple, very small, then no problem. Only with the single partition, one can easily access the data. Hadoop SSF and can. So just I'm interested to see how my output looks like. 3, 4, 5. Just we can make use of this convention of running through the task. So with this, just we can have a break, guys. So after the break, just I'll introduce you the notion of MapReduce one limitation. Okay, so and with respect to these implementation, there is no differentiation, friends. Whatever the programs, whatever the commands you are using, the same thing you can make use with your MapReduce 3 also, MapReduce 2 also. Only the differentiation is the cluster manager only distinguished. Okay, I'll talk about that. And moreover, we have to see in the MapReduce one, the job tracker taking everything, not only the job scheduling, but also cluster management, splitting of the task, and making use of all these observations, status information of the job. All these things were there. But whereas in case of our um, MapReduce II, it is only talking about resource management and node management. Your cluster management is clearly segregated to ARN, at another resource negotiator, where that particular ARN is responsible for performing the cluster-based activities. Okay, that is how we need to understand the things. Okay, so today with straightforward narrations only, friends, directly submission of the jobs in Python and Java context. So just have a look on that, just to prepare, understand how we are performing. If we are only having the MapReduce jar file, or if you are having source file, how do I export that? And then if you are having the Python-based files, so I'm not knowing Python, how to submit the jobs. Okay, that is the advantage of learning Hadoop, guys. Okay, you need not be pro in Java or Python. If you are having source code with you, straight away you can submit your jobs to the corresponding cluster. So that is the advantage. Um, with this, we are taking break. So this break, let me start the timer. Mm. Then once this timer starts, okay, so just you can assemble here, guys. Okay. So thank you very much. See you back. So, friends, I'm back. Please confirm.
Yes.
Uh, yeah, thank you.
Yes, sir.
Thank you. Rahul, thank you. Yeah, we'll start with
Yes.
our general discussion. Very good, Arvind. Uh, we stopped at understanding of some uh, submissions, job submissions, and we have seen some of the terminologies related to the ad. Now, let us see what is the why we need to talk about the ad and what is the reason behind that. Because though we are having MapReduce one, and what exactly the limitation of that particular ad of that MR1. So, just I'm giving some kind of insight things from the earlier session. Um, the very first point is if you observe the kind of nodes, so in case of the Hadoop 1.x, so just we'll be having some kind of the services, name node, data node, and thereafter we are having some nodes. So name node, data node, secondary name node, prefix, and we are having the job tracker, and then we are having the task tracker. Okay, so up to these three things related to Hadoop distributed file system, these two things related to MapReduce that we know. Apart from that, we observed one more point where there is a single point of failure. So single point failure, both in terms of the name node, we are facing the single point of failure, and in case of the job tracker also, we were facing the single point of failure. Now let me put this context. Okay, how name node single point of failure handled in Hadoop 2 or 3, because most of the characteristics are same things, 2 and 3. Very less distinctions are there. So how they manage this name node single point failure is along with okay name node. Okay, the designers established okay, a name node called passive name node. Passive name node. So that means immediately, if any problem is there for the name node or active name node, this passive name node exists. Okay. And second important thing what they have done is in Hadoop 2 or 3, your secondary name node is optional. Okay, it is optional thing. This is not mandatory. The reason is you pretty know that because as I'm having the active name node and passive name node, uh, even in case of the secondary name node, there are some differences between name node and secondary name node because secondary name node is not hard backup, is not hard backup of name node. Hard backup you pretty know guys. Immediately whatever the activity is taking place, that activity related to or registered with the corresponding machine. That is a secondary name. It's not definitely a hard backup. So there is a image distinctions and as well as the some of the aspects may not reflect into the secondary name node. So that means as it is, I may not get back the name node image in case of the Hadoop 1.x. But what they have done in Hadoop 2 or 3 is simple. Active name node is same to the passive name node. And if any problem is there, if any failure is there, okay, if any failure of active name node, okay, there is no data loss. Okay, there is no data loss. So with passive name node, okay, with passive name node, one can achieve all the okay functionality or status of metadata. Okay, so this is the designers could able to solve this thing very simply, guys, because in case of Hadoop one, we face two problems. One is single point failure of the name node, that is that could able to handle clearly with the corresponding members. Okay, now related to the second one, the job tracker. Okay, this is not that much easy, guys, because as always I can say storage wise backup is enough. Okay, storage wise backup is enough, or efficient management of other storage is enough. That's why your name node is managed as active name node and as well as the passive name node. There the problem is got solved. But our job tracker case is different. Job tracker single point of failure. Assume the situation here. Assume the situation here. See, the job tracker fails means there is no job scheduling. Okay. No job monitoring. No cluster management. Um, no job split to task. Okay. And moreover, no speculative execution. So to solve this particular thing, they struggle like anything, guys, because in case of the name node failure, they could able to come up with a nice analysis. So and moreover, they are there are certain complaints related to MapReduce one. The problem here is you need to think in terms of mapper and reducer. Always we may not implement every application in the mapper and reducer. And MapReduce one highly supports Java-based applications. Okay, so now with this, just they came to one conclusion. Okay, this the current thing is not going to work out anymore, and only we need to perform job MapReduce kind of the job. Other than that, I am unable to perform any kind of the activity. And moreover, they realized that this job monitoring and resource management and everything is done by the job tracker. So job tracker overburden is one of the important point they have observed. Okay, and moreover, friends, in case of the MapReduce, which is good for summing, grouping, or filtering or joining of the data, batch jobs. Okay, whereas analyzing on one entire large data set, and if your algorithms are parallel, so these are all suitable conditions for the MapReduce. And MapReduce guys here, there are certain problems with respect to the MapReduce orientation. Uh, MapReduce is not exactly good for certain conditions, friends. Let me pick up one data for you. So just you can see where we are struggling so as to cope up with the MapReduce orientation. Have a look on this, guys. So your not only that name node and as well as the job tracker, that is one problem actually. So job tracker overburden maybe by supporting one more node, we can segregate the task that they are very clear. But how to solve these kind of the problems? We see jobs that need shared state or coordination. MapReduce tasks are shared nothing. They are not allowing us to share the appropriate task and all. Shared state requires scalable storage. Scalability in the sense I can enlarge the appropriate functionality and all. And low latency in the jobs. So latency, guys, high latency is also problem, but low latency in the sense once the job is started, the way MapReduce runs is it is not going to move back or it is not going to interact with any other substitute. Okay. And the problem is the jobs on small data sets. As I said earlier, if you are having big data set, rather I'm having smaller data sets. So this particular environment is not suitable for your MapReduce one. Okay, your MapReduce is not suitable for that. And especially the point records. Point records in the sense maybe I want to pick up some records based on certain condition like how SQL and Python helps us, even in Java also. For those kind of the scenarios, this is not a best fit, guys. So with this, the developers, the designers felt that it's not only the job tracker solution, but we have to handle all the above points, all the above points. Then they decided this actually. Then they decided, okay, so this is not reducing the overburden of the job tracker, but something we have to do. And as a research, okay, as a research, they are having the solution of this Hadoop distributed file system. Okay, HDFS2. Of course, rather than talking, just let me pull some few points. This particular HDFS2, okay, what it does is because first we are solving that issue of the name node and all. No? So have a look on this guy. So removes tight coupling of block storage and namespace. Block storage already we have seen. Like if I want to perform some kind of the activity or storage related to the file, those files are going to split into the blocks and they are mapped into the corresponding data nodes. Okay, and according to the block size, okay, just one can easily access the data with the help of the name node metadata and remove that tight coupling of block storages and namespace. Second thing is high availability. Okay, high availability in the sense in case of name node, there is a secondary name node and it takes some time so as to recover. But with the advent of this active and as well as the passive name node, within no time, passive name node can take care about all the functionalities. Of course, scalability automatically increase, and because there are certain restrictions in Hadoop one friends, up to 4,000 machines or something you can add. All these kind of the things are resolved in HDFS2 and performance wise also. Obviously, guys, if I'm reducing the recovery time, okay, reducing the recovery or backup time, and as well as I am giving more scalable, then of course, as a as a common statement, as a single statement, I can say the performance can increase. Obviously, the that is the one of the important achievement. So rather making use of that name node and all those kind of the conventions, so just one can easily go through and preserve the orientation of this Hadoop distributed file system with the usage of whatever the functionality I want. Okay, like extension of the server, extension of the machines, or performing the activities related to the scalability, all those kind of the conventions. Now let us try to understand some other distinction. Here you can easily see the emblem is not only the difference trends, but there are certain meaningful distinctions between the understanding of Hadoop 1 and Hadoop 2. Now it is pretty clear for you what is MR1, of course, related to Hadoop 1. Okay, whereas MR2 related to Hadoop 2, and as well as along with because MR2 is different. That's what I said. ARN is different. ARN, of course, from Hadoop 2 onwards, we are venturing this ARN. Okay, now let us try to understand, guys. So batch because the entire Hadoop follows the batch processing. Hadoop follows the batch processing, and still HDFS2, HDFS3, HDFSN, all those are following the distributed environment and as well as the batch. And if you see, there is not much differentiation between HDFS1 and HDFS2. Only the above mentioned things are there, no? HDFS2. Except these things, everything remains common sense. That means whatever the name node functionalities we're having and how the name node behaves, metadata maintenance, there is no much difference in between Hadoop 1, 2, 3 or something. But the majority of the distinctions are happened in the parallel processing programming model of Hadoop. So this is not new for us actually. So in the earlier discussions, what we have seen, guys, just if you see the Hadoop, which is a combination of the HDFS, this we are pretty clear now also. No matter whether 1, 2, or 3, whichever, we reasonably managing the things. But here, in case of the MapReduce, the discussion would happen around this thing only. Okay, because now onwards, there is no separate term called MapReduce. Either you need to specify these things, whether you are using MR1 or MR2. MR1 you are using, obviously, those things are there, name node, secondary name node, job tracker, task tracker. These things come into the picture. Now MR2, if you are talking, of course, active name node, passive name node, no more job tracker and task tracker. Here we are having resource manager, node manager, these things. To run this particular MapReduce job, there is a separate cluster management tool called AND. Okay, MR2 now only consisting of the services. MR2 is not having any cluster management techniques or something like that. MR2 is hardly is a programming model. From starting of this session, we are saying parallel processing and which is a simple programming model. Hadoop follows that programming model is a MapReduce. Still, we are sticking to that point only. But if at all you are talking about MR1, and immediate point that should come to your mind is, okay, this is MR1. Obviously, I am using the Hadoop one name node, secondary name node. Of course, secondary name node is not the hard backup. So I am while processing the MapReduce one, I am having the job tracker and task tracker. Job tracker is overburdened, however. Everything cluster management, resource management, job scheduling, splitting of the job into the task monitoring, all these things should be done by the job tracker only. So this is a basic understanding while talking about the MapReduce one. Okay, it should be understood, guys, like that. MapReduce one in your team, if someone is talking about MapReduce one, that means there is no ARN, there is no kind of resource manager, node manager. Everything should be revolved around name node and as well as the job tracker. Okay, that is the thing. But in case of the MapReduce 2, we are pretty clear that uh, what they have done is HDFS turned into the HDFS2. They manage the active name node and as well as the passive name node. Instead of the job tracker and task tracker, they separated the appropriate aspect into resource manager and node manager. Actually, our problem is not to rename the job tracker and task tracker. It won't serve our purpose. They realized that okay, let us separate the cluster management and job running in a different way, like establishing the job and using the components, usage of the components. All these things are one side. and you can submit your job to the YARN cluster. Okay, now you see the diagram. Now you can pretty easily understand this process. So in case of the Hadoop one, your cluster management, data processing, both are in the MapReduce. There is no separate data processing. There is no separate cluster resource management. All these two components are subparts or byproducts of the MapReduce. Have a look on this Hadoop 2, guys. Actually, this particular Hadoop 2, which is not only running the MapReduce, this is the advantage, guys. See, the point here is in case of the Hadoop 2, we're having two zoners. It is not leaving the MapReduce process. Still, some people are there who are really passionate about the MapReduce. Of course, typical Java guys, typical Python guys, really supporting us in MapReduce processing. Of course, from the after completion of this thing, we are going to start with Hive, Piglet, and all these things, which are absolutely minimizes the lines of code. And one of the biggest complaint against to MapReduce is the code actually. So everything we have to implement, and of course, if it is Java, somewhat okay, because the native MapReduce kind of the coding is available with some kind of understanding you can do. But in Python, as you need to specify everything, friends. To give you a simple example, if I want to implement the combiner logic in Java of the MapReduce programming, only one line of the statement, set combiner class. That's all, set combiner class, and you can pass the mapper as the argument to the combiner class. Whereas in case of the Python, again you have to write the code for that. So for the combiner, especially, you have to mention if any repeated word is there, because there is no specific activity of combiner in Python-based context. Because see, as the avenues are open in Hadoop 2, that's what I'm talking about. This other data processing, other data processing. This means maybe I can venture the PySpark so as to develop the applications, a Scala, or of course Java. Java, however, you can do with respect to this thing also. So this point is why still Hadoop is in the market, guys. Because otherwise, if they are continuing with same old kind of the architecture, if they are absolutely arrogant to make use of those kind of MapReduce or batch processing or those kind of things, no one would have opted this Hadoop now, because as this particular Hadoop 2 opens the avenue for the other programmers also, for the other programmers also. So to notify you, see, that is the advantage guys, actually. Okay, that is the advantage. So they came up with this Hadoop 2, and they could able to support us with MapReduce 2. And this MapReduce 2 is a programming model where you can design your mapper reducer. And after designing this mapper reducer and driver code, if it is in case of Java, in case of Python, these two are enough. With the help of the streaming, however, you can submit the job. And what they have done is they established this YARN actually, which is a cluster management tool. See, the timing is most important, guys. The timing is most important. At the same time, in 2012, okay, definitely this is the valid point. In 2012, these guys, actually Databricks guys, released this Spark, okay, Spark on top of this Mesos actually. So Mesos is some kind of the cluster management. Okay, Mesos is some kind of the cluster management where we are going to run the Spark applications in on top of this cluster, and of course, which is backed by Scala. Which is backed by Scala. That means I can say like this: how your MapReduce, we are submitting the job, but your MapReduce should be backed by either Java or Python or R programming or anything. So such kind of the language is Scala, this Java or Python, and your MapReduce kind of the programming model is somewhat Spark, and you are submitting this job to YARN, that is something like Mesos. Okay, the point is pretty clear. Now the problem is Spark they like it very much, guys. Actually, due to their in-memory computing. Of course, it is also following the parallel approach. Okay, it is pretty nice. But their problem is this Mesos is absolutely a failure model of the cluster management. They don't want to club this Spark and Mesos. Okay, and obviously, what is the point coming to the picture? Can I run Spark on top of the app, which is a deadly combination? See the market is like that, guys. Actually, we cannot expect as how the politicians win in the elections and how a movie is getting super hit. So similarly, the products also we don't know, especially in the industry, which product is really gaining the understanding or potentiality because of course every product is they sweat like that they sweat like anything and they provide us kudos to these open source especially the entire Hadoop stack no matter entire big data stack especially Hadoop, Hive, Big Latin, Flume, Scoop, HBase and see the researchers and the practitioners like us have to thankful to them guys otherwise we end up with a proprietary and of course very limited members have access on those kind of things and there is no learning possibly of course we can but with the practical exposure and by downloading these things only we can fulfill the circle of learning actually and based on that convention yeah and I have to refer one more important guy here Apache guy. With Apache, they, of course, we are having entire Hadoop stack with them. And of course, ARN also their product only, no? ARN also their product only. Now this database they ventured because they never expected Spark with ARN. And surprisingly, in 2012 to 2015, this has created a nice impact and Python users started these guys Python users started asking, can you release a Spark version for us? Then the advent of PySpark happens. See, one part of, see, that is what friends, always you should be inclusive. Inclusive in the sense, based on the caste, creed, based on the community, if you try to uh, group with the people, your life is zero. No matter from which country that guy is, or which caste that guy is, which education that guy is, no matter, leave that. Inclusiveness is most important. Okay, due to the open source, okay, just that inclusiveness is possible. Now they think, okay, because Databricks, Databricks, they're having their own proprietary kind of this part. So they ventured, okay, already that Apache guys or giants in the open source, they engaged with these Apache guys also. Okay, that's what if you talk about Spark, though the invention happened at Databricks, but the distribution is taking place with Apache kind of thing. So we are happy with this thing, like due to the MapReduce 2, due to the ad orientation, it is not only helping Hadoop kind of thing, guys. And of course, while talking about maybe probably in the next weekend, after completion of this Hadoop tools, we are going to enter into the Spark. At that time, I'll clearly mention how Hadoop is complemented by Spark and how Spark is complemented by Hadoop. Actually, those two things are getting benefit from each other, guys. It's not like after Spark, Hadoop has been killed. No, that is a myth actually. Because Hadoop is having its own strength in case of distributed functionalities and MapReduce kind of thing. The same functionality can be leveraged to the Spark programming. Okay. So with this, just you see here, the ARM usage, okay, gives the cluster resource management. Here, other data processing in the sense you can use any kind of the technology, Scala, PySpark, Flunk, and we are using many technologies so as to venture these ARM kind of thing. And of course, you need not be a MapReduce Pro. You need not be. With the programming background we are having in the notion of PySpark or Scala, you can submit your jobs to ARM actually. That is what the cluster resource management. Okay, so if operating system is there and you can do whatever you want. So on top of that operating system, you can run your virtual machine or you can install your Java or Python or whichever. Okay, so with that, just the main important notion is that Hadoop 2 actually they thought of solving their issue, and by solving their issue, they opened the integration of many technologies in that. Okay, now you in a single liner, multi-purpose platform. This HDFS2 Hadoop 2 is a multi-purpose platform, and of course, batch processing is there, interactiveness is there, streaming is there. Both the three streaming, of course, with the Kafka, and of course, this Spark streaming is also nowadays gaining the potentiality. Okay, 2 or 3 days back, Harish asked one doubt, like, can we do streaming with Hadoop? Of course, provided you need to have the ARM. On top of that, we have to use Kafka or Spark kind of the streaming. And based on these kind of the techniques, one can maintain the convention of streaming and as well as the Kafka, the interactive and the streaming kind of the applications. Okay. So now we are pretty clear, guys. What is MapReduce 1 and MapReduce 2? I don't think now we are going to use MapReduce 2 and ARN interchangeably. We cannot use that, guys, because MapReduce 2 is a data processing parallel processing technique of the Hadoop 2 architecture. ARM is a gold actually, but ARM is something like which is a cluster management tool along with the resource management kind of the aspect, which actually created impact on the market trends actually. Okay, now this is the time to specify some kind of which are all the supporting apps related to ads. So now if you see, maybe you can have a look on this usage guys, how we are making use of this ad apps. Okay, so of course, Hadoop distributed file system still exist. The point is, MapReduce, however, depends on there is no change, friends. Maybe whether it is MapReduce 1 or MapReduce 2, that architecture they never touch. They have not touched anything on that. Now, as our favorite this thing, HBase, of course, this thing actually, Spark. Now there is a question whether Spark is having access on this thing. Yes, of course, Spark can make use of the HDFS too in a way by fetching the data or by fetching the input data from HDFS2. Spark jobs can be run on top of it. That is the equation there. So while working with the big data kind of the scenarios, if I'm having the huge amounts of the data, definitely the HDFS2, okay, just it is providing a platform for the many tools. Now you observe here how ARN is licensed between many technologies. Of course, MapReduce were pretty good. And one more interactive tool is there. Maybe a few people may be knowing about this stage. Very rarely used, but still it is the best part of the stage is interactive. And this is the NoSQL. I'll provide some insight of this NoSQL also, guys. Storm, S4, all these are the major partitions of this streaming graph. Okay, this is the Facebook invention. And in-memory computing, of course, this is our super success friend because Spark provides streaming, Spark provide interactive jobs, Spark provide batch. Okay, because while using some kind of HDFS aspects, you can enjoy that benefit. So, we're having plenty of these applications due to that ARN only, guys. Due to that ARN only, because of that ARN implementation, Hadoop is also blooming actually. Okay, so that decision they have taken so as to empower Hadoop. It's not only empower Hadoop, but also it created some one landscape for the appropriate data science or machine learning or data engineering perspectives. Because if I'm having the huge data and I want to apply some kind of the analytics on that huge data, definitely I should use the HDFS. And for the analytics, and Hadoop is not definitely for the analytics. Hadoop is for the storage and processing only. And Spark is definitely not for the storage. So if you combine these two, Spark is for the sake of the analysis, Spark is providing machine learning library, Spark provides many packages to handle the data engineering kind of thing, so as to handle the missing values or missing value imputation, feature engineering, like that. We're having many kind of aspects. So we are very equipped friends. Like we are having in our hand HDFS, we are having MapReduce in terms of Python and Java, and now we are talking about MapReduce 2. Of course, apart from Java and Python, if you want to uh, check your project capabilities with Spark, of course, that is also there. It's definitely a good moment for us as a developers of the industry. Okay, so we have to be very happy to have this kind of the convention. So this is one side of the story, guys. Now, what exactly the MapReduce 2 does for us? Because if I am referencing this architecture, so just I will touch base on this point, and so that we can conclude the session. I won't take much because we have to talk some other points also. So that I want to introduce the ARN orientation at a glance in a very high level perspective. And out of these kind of the things, friends, we know the some of the terminologies. Resource manager, we know. This is of course first thing. And node manager also we know. This thing we know. And third thing is job history server. Just now we have seen in the ARN kind of thing, we have seen the job history server. Okay. Now, observe guys here, the components of the node manager, resource manager belongs to MapReduce 2. Don't get confused because both the things are used here in the single statement. MapReduce 2 orientation, I'm having the node manager and resource manager. And with the ARN orientation, one more point we have added actually, job history server. And of course, friends, surprisingly, this ARN, not surprisingly, I can say logically. So logically, this ARN is having access on resource manager, node manager. A point is pretty simple guys, because if any problem is there for any node manager, who has to supply as a cluster management tool, ARN has to support that. Okay, ARN has to support that. If any failure is there in the node manager, if any problem is there in the status update, then ARN should come into the picture and it is going to solve that particular issue. So, which is making use of the convention. Okay, now have a look on this, guys. Just a simple narration. Um, Basically, that resource manager, which is providing the currently running jobs. Of course, we have seen that. Just we'll try to figure out which are all the points we know. Resource manager, current job status, current job status. And of course, resource manager get the status from the node manager. Resource manager get the status from the node manager, that we can see. Now, one more point, friends, actually. There is a communication between client and resource manager. Really simple thing. See, if you submit this job, Hadoop jar, mr1.jar, okay, then obviously this is enabling first ARM is coming into the picture, and then immediately ARM observing the resource manager. Okay, because the entire job information is available with the resource manager. Okay, that is the reason why here we can see the client is interacting with the resource manager. Okay, client job submission, and of course internally ARM plays setting up all the things and all. These things were pretty clear, guys. Resource manager, job history, and now the point is we should understand the perspective of the node manager. At a glance, I'm saying, guys, individual machines contains all the machines, friends. Whatever the slaves we are talking, individual machine contains node manager. How we have this is not a surprise to us because how the task tracker is distributing over the machines. Now you see, guys, here. Suppose if I'm considering a job is the combination of map task and reduce task. There also we have seen in the history server and in case of the resource manager server, in both the cases we have observed that we are having a map task, we are having the reduce task. This is actually the driver. Okay, because the driver, in case of the Java, directly we observe the driver, but in Python also indirectly ARM creates that particular driver kind of thing. So we have to be like that. Okay, the submission is like that. Now this is the driver or application master program, and there the container is something like okay, which is having the entire resources with it. Okay, suppose if I'm talking about the a machine. Suppose I'm teaching, and we are all from past 3 hours we are uh, communicating, and of course with the help of this Teams container because it is having the sharing option, it is having the chat option, and you can unmute yourself and you can talk with me. So all these particular things acts as a container. So this particular container is one kind of the package where it is making use of the task map and reduce kind of the orientation so as to complete the applications. With this, I'm stopping, guys. So just to go through this today's session, of course, we have done many kind of repetitions, okay, as a key takeaways and all. But of course, that's how we need to learn. So finally, I'm concluding the session with key takeaways. So just let me list out which are all the points. Java job submission we have observed in the context of after export of dot jar or else with only dot jar. In both the cases, we have seen how to do that. And in the second consideration, we observed the combiner and partitioner logics, combiner logic and partitioner logic. And then we observed the ARN infrastructure kind of thing. There we observed some kind of the points. And next one, we have seen some MR1 limitations. And thereafter, we studied about that Hadoop 2. And they given us the MR2, HDFS2, and of course, ARN as a separate cluster management tool. Then we are talking about MR2 and ARN high level view. And this particular high level view, we have seen that we're having some container. Within that container, we're having map task. application master, reduce task. Okay, all these things are available in the node manager. And each and every machine is having the node manager, and which is going to report the status to the resource manager. And we are along with that, we're having the job history server and client is the submission of the jobs. So these things we have observed in the today's session. And coming to the next session, what we are doing here is, guys, out and out ARM discussion. And again, we'll go back to that ARM cluster. We'll try to use some of the narrations, guys. And let me see if I can start with Hive as alternative to MapReduce coding. Because MapReduce, why people fear is they should know the Java or Python. And of course, as a Hadoop developer, either we should get the .py files from external users, or we need to get the source code of the Java, or we should get the .mr, .jar files. But rather, you can also implement your own kind of the applications with the help of the Hive. So Hive is simply the ETL kind of the tool. Many, especially in our company, and of course, we are heavily using this SQL, Python, and Hive. So which is really going to benefit you guys. But without understanding the problems in MapReduce, the problems in MR1 and MR2, MR2 problem is only coding, friends, nothing else. Okay, because some people won't like that heavy coding. So they can go with these Hive, Piglet, and Scoop according to their requirement. That's all, guys, from my side. And I'll be posting some kind of the tasks, and just be attentive. And of course, the concepts are like that, guys, because if I'm teaching maybe SQL, Python, it is pretty simple. And you can listen to me and you can directly practice. But here, practicing is pretty simple, but understanding the architecture and going through this architecture is many points are there. No? Many points are there and quite interesting. So that is what how you can follow the lecture. Okay. That's all, guys. And if you're having any doubts, please let me know. I'll stay back up to 1 or 2 minutes. Otherwise, you can contact me through Teams or Slack so that I can resolve that. Okay. Right. How many of you have installed? Harish, Sahu?
Not yet, sir.
No problem. Yeah, I
Right,
can do
sir.
one thing
Yes.
also. Yeah, guys. Actually, one more support guy is there for us. DB architecture and architect, and he said that okay, so if some of the team members are very much interested to install, I'll allocate the AWS cluster so that they can install in that cluster. Provided if your machines are not supportive, so he can allocate you some AWS space. Okay, maybe 2 or 3 days you can play around that cluster, maybe by using this. Because some days before we have tested that Hadoop. It's properly running, guys. Actually, Hadoop 3 I have seen. So just to try, there are three alternatives, friends. One is you can download the Apache software and you can configure as that of the document I have provided. Second thing is ready-made virtual machine, maybe with the help of Cloudera or Hortonworks. Directly you can download and make use of that. Even Edureka or some other providers also, they are open to give this kind of thing pre-configured. Third option is that I'm saying maybe we can request the support guy so he can give the AWS space for us within 2 or 3 days, maybe maximum 1 week. So you can make use of that space and utilize the opportunity of running through that. It all depends on your again the interest and all that. So that's it, and that's all from my side. Keep in touch, and of course Monday you guys are giving Vedant, Harish, and Asru.
Yes, sir.
Hope you
Yes,
Presentation.
sir.
and please.
Yes, sir.
Okay then. Thank you. Thank you very much. And meantime,
Thank you.
I'll be asking some other guys also to compare and contrast Java-based submission, Python, MR1 and MR2. I'll be posting soon in the Slack friends. Okay. So next week we'll, as a combination, hybrid mode, kind of the classes can be there. So the repetition of the earlier ones by you, some of your friends, and however, I'll be teaching this high scoop as usual up to the Spark orientation. Okay. Thank you. Thank you very much for your patience and happy weekend, guys. Just to have a look on all these kind of the topics, just go through, uh, just be attentive and prepare well, right? Thank you. Thank you.
Thank you, sir.
Yeah,
Thank you,
thank you.
sir.